Hey guys, it's Axiomatic Uncertainty here, and today I figured we might do something neat again. So, we're going to be doing a simple thing, which is going to be a proof. I haven't done a lot of these on this channel, actually. So, the proof is going to be proof. Not really a proof, actually. We're going to derive the formula, essentially, for the derivative of f of x, or f prime of x for f of x. Excuse my writing being so bad. A to the x, right? So f of x equals a to the x. So let's just get started with that. First off, I'm just going to basically just crop this whole thing out. Wrong way, sorry about that. On color, let's make that color white. Just do that and that. Okay, so that is pretty simple. So our goal is to derive the formula for the derivative of a to the x. Now, to start, and despite the fact that we have prior knowledge, we're just going to be proving using this. We know that the derivative of e to the x is equal to e to the x. But we'd like to prove that, so for this video's sake, we're going to do that. So, we're going to say f of x equals e to the x. And I will explain why we're doing this afterwards. So, we have this. Now, what we need to do is we need to set up the limit, so limit as h, I use h instead of delta x because it's easier to write, tends to 0 of e to the x, to the x plus h, and then minus e to the x. And all of that divided by h. So, this would be our simple limit. Now, we can factor out this here and derive a new formula, which would be e to the x times the limit. Sorry about this video being so slow. Obviously, I can't go much faster than my writing. As h tends to 0 of, now we have e to the h minus 1 divided by h. So that's quite simply what we're looking for here. I'm just gonna take my white color, here. Oopsie. I don't know what's going on here. There we go. Okay. Take my white color and just color over that because I didn't like that. Can't really read it that way. Now that we have this, we need to go one step further, and we need to keep going. So, essentially, in order to prove this, we need to understand first. Let's just get down our e to the x times then the limit as h goes to 0. This is h tends to 0 of this next bit here, which is going to be e. So e. Sorry about that. E to the h minus 1. Now, before we do this, I'd like to discuss something, which is a definition. So, definition. Right? E is equal to the limit as h tends to 0, as h tends to not 0, but infinity of 1 plus 1 divided by h to the h power. Now, in our case, h is going to 0. So this needs to be h goes to 0. How are we going to do that? Well, we can rewrite this as limit as h tends to 0. Well, how do we make it so that as h tends to 0, this number here, which is originally getting closer and closer to 0, is getting closer and closer to 0 again? We just make it the reciprocal of each of these. So 1 plus h to the, and then if h is going to 0 and we want it to go to infinity up here, the power to go to infinity, we just do 1 over h now. And now this is our new definition of e. So this is our revised definition of e. Now, we need to substitute that in here. So we can write here now 1 plus h to the 1 to the 1 over h, but we mustn't forget that this is all being raised to the h power, because obviously up here it's e to the h. Now, we need one more thing, which is this minus 1, and then divide it all by h. It's starting to look like Christmas here. So this is all equal to that. Now, down here, we need another here, and as you can see, this is very important, because we can multiply these two. H over h is going to cancel, and we'll be left like that. So now we have e to the x times the limit. Okay, let me rewrite that. That's a little bit sloppy. As h goes to 0 of 1 plus h minus 1. So just write that in this color here. Actually, I'll use this. 1 plus h. I really like using these paint colors. They're fun. Over h. Okay. Now, as this gets closer to 0, as you can see, these don't even matter. They cancel. So we have h over h. And this is just going to then be equal to, e to the x times 1, and this is all equal to e to the x. So, as you can see, we've just proved that. Very logical steps there. So now we just cover this up. Actually, yeah, that's fine. And then we'll have to go with this paint bucket thing here. Just color over that. Okay, so let's get our brush back and go back to this color. Now that we know that the derivative of e to the x is e to the x, we can use the chain rule, which, as you know, says that if we have a function f of g of x, we can say that this is equal to f prime of g of x times g prime of x. Okay, so that is the chain rule. Sorry about my writing being so lopsided. Right, that is the chain rule. So, what are we going to do with this? Well, if we have f of x equals a to the x right? We can rewrite this as e to the ln x times x. So let's just rewrite that as x ln x, right? So now, actually, yeah, that's perfect. So now we know that we can differentiate this using the chain rule and the fact that we've now proved that e to the x has a derivative of e to the x. So for the derivative, what we're going to want to do is we're going to want to take e to the x ln, oh, not x, that's a, sorry about that. Almost missed that, because obviously this is the logarithm a to get this. Okay, so I hope you're following still. So we're going to say right, d dx of e to the x ln a, right? Finally, now we can do the actual differentiation. Very simple. E to the x ln a, right? Times, then, the derivative of this bit here, which can be expressed using the product rule. So we can do derivative this part, which is 1, so ln a, right, because we got 1 times this other section here, plus then derivative ln a, which is 0 times this. Actually, we didn't even need the product rule. I don't know what I was thinking there. I did that x to the x video and I kept thinking a is not a constant, but a is a constant, so actually we already know that it's just ln a times derivative of x, which is 1. So we have e to the x times ln a. And yeah, that is the formula. So we've successfully derived the formula. So I guess actually we can simplify this a little bit. Just say a to the x ln a. Okay, so that is our derivative fully simplified. Let's just put a times in there so it's clear. And let's just write this out just for clarifying. There we go. So derivative of a to the x is a to the x times ln a, and that's what we've shown through these proofs. So I hope you enjoyed this video. More videos like this will be coming soon. Obviously my writing with a mouse is pretty tragic right now, but it'll be getting better. It will be getting better. I think, you know, it's even improved since earlier today when I posted that other video. But I just thought this would be a cool thing to do, so I hope you enjoyed it. Thank you.